Hello everyone, this is the sixth lecture for the unit number 5 of the subject Mechanical Measurement and Metrology, and in this lecture we are going to check out the strain measurement. We will be checking the introduction of the strain gauges. So the content of this lecture are the introduction to the stress and strain. Then we are going to check out the strain gauges, which are mechanical, optical and the electrical. So let us start with the lecture. Now, a stress, whenever the external force is applied to the rigid body, a resistance force is developed internally, or we can say inside the body, to resist that applied force, and that internal force is known as stress. Mathematically speaking, a stress can be defined as force applied per unit area, or we can say the resistive force that is basically developed per unit area. Okay. When we talk about strain, strain can be directly defined as the change in length per unit original length. Okay. So whenever we talk about strain, strain is a deformation or displacement of the material, which is basically the result of the applied stress. Okay, so whenever we apply the external force, internal stress will be developed, and due to that, what will happen? There will be the change in the length, and that particular change in the length per unit original length will be known as strain. When we talk about measurement of the stress and strain, stress measurement cannot be done directly, very first, but we can measure the strain, and that can be done with the help of the strain gauges. Now the question arises, why we need to measure the stress and strain? When we talk about design and construction of the machines and the structures, it becomes very necessary to know whatever the mechanical component or any structure that we are actually manufacturing or developing can carry the load which actually demanded without any kind of excessive deformation or failure or not. Okay, and that can be done with the help of the measurement of the strain, and that is why the stress and strain plays the very important role when we talk about the manufacturing or development of anything. So let us start with the types of strain gauges. There are basically three categories of strain gauges. Very first is mechanical strain gauges, second are the optical strain gauges, third are the electrical strain gauges. In the electrical strain gauges, especially the electrical resistance strain gauges are one of the most popular devices because they are having, or say they can offer many advantages whenever we talk about the process of measuring the strains. Okay, so we are going to check out the electrical strain gauges in a separate lecture. Today we are going to check out these two type of strain gauges. Initially we are going to start with the mechanical strain gauges. Now mechanical types strain gauges basically uses the mechanical devices like levers and gears to magnify the change in the length that is made on the test specimen during the stress testing. Okay, so this type of strain gauges were initially developed as an extensometer, and they were initially using the simple lever mechanism. Now at the initial stage, the extensometers were able to get the 10 times magnification. But nowadays, with the compound lever mechanism, we are actually able to get more than 2000 times magnification. And some of the most commonly used mechanical strain gauges are Barry type strain gauges and the Haagenbugger strain gauges. So let us check out this kind of strain gauges. So very first device is the Barry type strain gauge. The Barry type strain gauge basically uses the lever magnification with a dial indicator. So let us check out the construction of this strain gauge first, and then we will see the working of such kind of strain gauges. So as you can see over here, one frame is available, and on this frame there is a fixed pointer available. The second pointer is available over here, which is actually a lever mechanism. This is a lever mechanism with a pivot available over here. The first set of the lever mechanism, the length of this particular part is high, and the length of this particular part is actually comparatively lower than this length. Okay, the pointer is available on the vertical side, and on the horizontal side a dial indicator is attached, and on this dial indicator we will be able to measure the change in the length with the magnification. This is the spring attachment for fixing the whole mechanism on the test specimen. So this was the construction of the Barry strain gauge. Now let us check out the working of the Barry strain gauge. Now very firstly, this strain gauge is fixed on the test specimen. Now very firstly, the force will be applied on this trace specimen. So some elongation will occur. Now when the elongation will occur, or we can say the change of length will occur, what will happen? This movable pointer will move in the direction of the change of the length, and due to that the second end of this particular lever will try to move in the relative direction, and due to that movement this dial indicator will capture the change of the lever, and then it will show the readings of change in the length. This is how the Barry strain gauge will work. Now let us check out the second strain gauge, which is known as Haagenbugger extensometer. Now this extensometer basically has the set of the compound levers. Now due to these compound levers, what will happen? The whole extensometer will be relatively small in size, and we will be able to get the higher magnification factor. And as this is a mechanical gauge, the accuracy will be higher. Now let us check out how the magnification factor will be higher than the previous extensometer, or say load cell. So in this particular extensometer, you can see that this is the fixed knife edge pointer, and this is the movable knife edge pointer, okay, which is fixed over here on the frame. Now this pointer will be able to move in the lateral direction as well as the transverse direction also. Now as you can see, the second of this pointer, or say this lever mechanism, it is attached with a link, and this whole link is actually attached with the second set, which is actually a pointer, and this pointer is attached with a pivot available over here. So whatever the motion will occur in the movable pointer, that motion will be transferred to the link, and link will transfer the same motion to the pointer. And due to the two pivot points available and the compound mechanism available, the pointer will be able to show the highly magnified value of change of length on this particular scale. Now working of this Haagenbugger extensometer is almost same as the previous Barry strain gauge extensometer. Okay, and we are able to get more than 2000 times magnification if we can apply the dial indicator on this extensometer. So this is how the Haagenbugger extensometer will look like. Now let us see some of the advantages and disadvantages of the mechanical strain gauges that we have seen. So very first, in the advantage part, as it is a mechanical device, it is a self-contained device. Okay, so it is basically a self-contained magnification system, so there will be no auxiliary part required. in case of the electrical requirement, there is always a requirement of the power as well as the auxiliary parts. Okay, so this is the basic advantage that we received as they are the mechanical strain gauges. But over that, we are having many disadvantages. Very first, the mechanical parts are comparatively larger and they are suitable only in case where the sufficient space is available on the test specimen for the mounting such kind of gauges. Okay, so if the test specimen is smaller, in that case it will be bit complicated or it will not be possible to measure the strain with the mechanical strain gauges. Secondly, as they are having higher in inertia, mechanical strain gauges are basically having the higher in inertia, so such kind of gauges make it unsuitable for the dynamic measurements. Whenever the measurements are continuously varying, the strains are continuously varying, in that case we are not able to measure the strain. Okay, and there is no method available for the recording. Okay, we can only check out the readings directly, we cannot record the readings, and also the human is required for viewing those readings. And lastly, these gauges are basically employed for the strain measurement only, and also in case where the point of measurement is accessible for the visual observation, then and then we will be able to employ such kind of devices. So these are the major disadvantages of the mechanical strain gauges. But still, nowadays, with the combination of mechanical and the electrical as well as the mechanical and the computer mechanism, we are able to measure the strain because they are actually highly accurate. So these are some of the examples of the extensometers and the strain gauges which are actually used in practice. Now let us check about the optical strain gauges. Now, optical strain gauges are basically very similar to the mechanical strain gauges, except the magnification mechanism is different. In this case, the magnification is achieved with the help of the multiple reflectors. Now, what are the reflectors? Reflectors can be like a mirror. Mirror is one of the reflector. A prism is one of the reflectors. So, such kind of reflectors are used to magnify the change in the length. Now, when we compare them with the mechanical strain gauges, basically the inertia of the optical strain gauges are reduced compared to the mechanical strain gauges. Okay. Now, secondly, the measurement accuracy of the optical strain gauges is basically higher compared to the mechanical strain gauges, and lastly, they are independent from the changes in the temperature. So, temperature variation will not change any kind of readings. Okay, and some of the most commonly used optical strain gauges are very first the Martin's mirror type extensometer, and the second the Tuckermans optical strain gauge. So let us check out them one by one. Very first one is the Martin's mirror type extensometer. Now in this kind of extensometer, a single mirror system is used. Okay, let us check out how the construction is there. This is the stage specimen which is available over here. This is the fixed arm and this is the movable arm. Okay, now on this movable arm, one mirror is fixed. This is the mirror which is available over here. Okay, this is the clamping spring which will be used for the clamping purpose, and at the second end, as you can see, there is one scale available over here, and this is the telescope. Okay, so these are the things which are available in the Martin's mirror type extensometer. Now, when we will apply test stress on the specimen, in that case, what will happen? The length between these 2 points will change, and due to that, what will happen? The angle of this particular movable knife edge pointer will change on which the mirror is attached, and with that the mirror inclination will change. Let us say that mirror inclination is changed to value of theta. Okay, now this particular change in the inclination is measured with the help of the telescope. This particular telescope is fixed, okay, and whenever we see from this telescope, we will be able to see this particular mirror, and on this mirror we will be able to see the reflection on the scale, okay, and this particular inclination will be 2 theta. This is what we need to remember, okay. So normally the scales are calibrated such a way that it will directly show the value of the theta instead of the 2 theta, okay. So whenever we see this particular scale, we will be able to measure how much change is done on this particular test specimen, because this theta will be calibrated in terms of the change in length. This is how the Martin's mirror type extensometer will work. Now the second device is the Tuckermans optical gauge. This is one of the most commonly used strain gauge in this particular category, which was developed by the L.B. Tuckerman. Okay. Now it basically uses the combination of the mechanical and the optical system. Okay, and it consists of the two basic parts. Very first part is the extensometer itself, and the second part is the autocollimator. Now this autocollimator is basically creates a beam of light with a scale which will be reflected once again, and we will be able to measure the inclination that is being done, or say the changes of the length that is being done on the second end. Okay. Now the detailed discussion of the autocollimator is already available in the angular measurement section, so you can check out that particular discussion. Now we will continue with the Tuckermans optical gauge. Now over here, as you can see, there are two mirrors available. Very first mirror is available over here, which is the fixed mirror, and the second mirror is available over here, which is basically the tungsten carbide rocker, which is also known as lozenge, or it looks like a rhombus. Okay, so very first, this is the fixed knife edge end, and this lozenge will work as the movable knife edge end. Okay, so whenever the test specimen will be under the stress, whatever the change in length occurs, according to that this lozenge will move, and due to that this particular mirror will also move. Many times this is not an actual mirror, the material is basically polished and the reflection of the rays will be done over the material directly. Okay, so over here the ray will come from the autocollimator, and it will be reflected first from the mirror number 1, and then it will be reflected from mirror number 2, and then it will return to the autocollimator, where we will be able to measure how much change in the inclination has occurred. And if this autocollimator is calibrated, in that case we will be able to check out directly the change in the length, and if it is not calibrated, in that case it will show us the inclination that is occurring over here, and we will be able to change that inclination in terms of the change in the length. This is how the Tuckermans optical gauge will work. Okay, so basically this kind of optical gauges are actually capable to measure both static and dynamic strain, because they are directly giving us the value without any kind of inertia. Okay, so we will be able to see the real time changes in the strain directly. Now let us check out the third variety of the strain gauges, which are the electrical strain gauges. We are just going to see the introduction of the electrical strain gauges, then we will be discussing this kind of strain gauges in detail later on. Now the basic principle of these electrical strain gauges is this one: a change in strain produces basically the change in some electrical characteristics. Okay, so when we talk about the changes in the strain, what will happen? It will create the changes in the resistance, capacitance or inductance of that particular material, which will be directly proportional to the change of the strain. Okay, so this is the basic principle. Now this kind of strain gauges can be classified as resistance strain gauges, capacitance strain gauges, inductance strain gauges and piezoelectric or semiconductor strain gauges. Now as we talk in the introductory parts only, the resistance strain gauges are one of the most popular type of strain gauges. So our concentration will be on these strain gauges only. Now the capacitance type strain gauges and the inductance type strain gauges has some special applications. Okay, they are not most commonly used, but they are having some special application. And thirdly, the piezoelectric and semiconductor strain gauges has also some of the limited applications available. Okay, so these strain gauges will be studied in the later parts. Let us check out the advantages of the electrical strain gauges. Why these kind of strain gauges are most popularly used or say most commonly used. So these are the advantages. Very first, it is very simple in the construction. It has a very less inertia impact. So they are actually very sensitive to the changes. Okay. Thirdly, they are very small in size and that's why they can be installed in any place. Okay. And even if the place is not that much easily accessible, as they are very small, they can be actually used over there also. Next, the output of the gauges can be utilized for the recording and the indicating purpose also. It can be also indicated on the LEDs. It can also record it on the recording devices. Next, they can be calibrated for the variety of properties. We can actually not only measure the strain, we can also measure various kind of things, mechanical properties, like we can directly measure the force, we can directly measure the pressure, we can measure the acceleration. Okay, so such kind of mechanical properties can also be easily measured with the help of the electrical strain gauges. And lastly, one of the most common use or say most common advantage, they are basically very reliable and very inexpensive. So these are some of the most common advantages that makes the electrical strain gauges most popular. So this is the end of this specific lecture. In the next lecture, we will see the gauge factor and then we will see the theory of the resistance strain gauges. So till then, keep learning. Have a good day.